Okay, welcome to week 4. Hope everything's going well in your semester. Things are going pretty good in mine, a bit busy, but I'm sure you all understand that as well. Participants and sampling. So it's a very important thing, especially in quantitative studies, but really even in qualitative, and we'll talk about that more a little bit later. But we want to go over why sampling is important, how to do it, different types of sampling, and then how you can evaluate what's a good sampling procedure. For one, so when you're reading research, you'll be able to know, is this a valid claim that the author's making? And two, when you create research, even your proposal for this class, you'll need to put some kind of sampling plan in your proposal. So participant is the preferred word for someone who's participating in a study. The word used to be subject here, but if you've heard anything about the type of research that was done 100 years ago, where, for example, some people were injected with syphilis down in the South, just so that the scientists could then test different types of treatment, or even gave treatment to some people and not to other people. But these people were just going in for checkups, they thought, medical checkups, and then were infected with syphilis, and many of them eventually died. The Nazis also did some really horrible research on people. So we typically like to think of doing research with people these days. There's many more laws in place, many more guidelines, and we think of someone in a study as participating with us in the research process, not as a subject that it's done on. And the sample is the group that we're dealing with in the study. So in quantitative studies, we often do what's called probability sampling. This allows us to make a claim that whatever we found in our sample group, we have a rough idea of how well that can be generalized out to the population. So population is the group we're interested in, but we can't always get at it exactly, so there's what's called the accessible population, the ones that we actually could potentially have access to, and then our sample is even smaller. So you have your total population, your accessible population, and then your sample is the group that you actually work with. So population can be a little hard to get a hang on at first. Let me give you an example from my teaching. So this semester I'm teaching 5 classes. Your class, and then let's contrast it with a pre-calculus class that I'm teaching. So your class is graduate students. Many of you have a lot of life experience. You know why you're in education. Well, I shouldn't presume that, I'm sure. There's a fair number of you who are still struggling with purpose, as I was and am. But you certainly have more purpose for being in the classroom than, say, some of my pre-calculus freshmen who are fresh out of high school. So when I think of my teaching methods, and maybe I'm trying to refine them, I have to be careful. Am I talking about methods that will work for all students that I could possibly have, or are they methods that will work in my graduate classes versus my entry-level undergrad classes? And sometimes it's both. Sometimes, for example, respecting students when they come to me with a question, or emailing quickly when I get an email, replying quickly. These are practices that I've found work well for people in general. So they work for anything, for grad classes or undergrad, versus certain types of discussion boards, for example, tend to work much better with graduate students who are more invested in it than they do for undergrads. So in that case, when I'm looking at discussion boards, maybe my population, my target population is just grad students or just undergrad, or maybe just undergrad non-math majors or just undergrad math majors. So that target population is an important piece. And then this margin of error idea is that when you have this population you're interested in and you take a sample out of it, you're not necessarily going to get exactly a picture of what the entire population is like. This is called sampling error, and anyone who's done some teaching will know this. Like if you're teaching 8 classes within a school, even if it's the same prep, it's the same class, all 8 classes, the groups of students that you get in those 8 classes can be very different, or they can be different from year to year. This idea of sampling error, that the sample represents a larger population, but it's kind of a fuzzy representation. That's why we have this interval. When we come up with a guess at a population parameter, an estimate, this is called our statistic. So we do a study, we calculate a mean from our sample. That's probably not exactly the population mean, but it's a good, if we have a reasonable sample size, it's a good estimate. But we usually create a range around that sample mean that we think the real population mean lies in, and that's called a confidence interval. Okay, so some different types. We'll go through these fairly quickly. Simple random is often the gold standard of probability sampling. So we have an entire population list. We have somehow represented every single person in the population. And then we come up with a pseudo-random generator or some kind of random generating number thing to match those numbers and pick out a sample. That's often the best, except for certain situations, which we'll talk about in a second. Systematic is similar. You need a list of the entire population. If you don't have an entire population list, you cannot do simple random or systematic sampling. So you need that entire population list. Once you have that, then say every 5th person or every 10th person or every 20th person on your list, you pick out and put in your sample. There's really not much reason to do systematic sample. If you get an entire population list, which is often very hard to do, you might as well do the simple random sampling because it's got less chance of having bias created by some kind of pattern that's hidden in the numbers. Stratified sampling, so this would be a reason when simple random sampling might not meet your needs. Let's say that you're looking at students with autism and you have access to 900 male students and only 100 female students who have been diagnosed with autism. But at the same time, you want to see things like, are males and different females with autism treated differently, or they respond differently to social interaction in the classroom, things like this. So maybe you want to guarantee that you get some of those females in your study. You don't want to take the chance that you're only going to get males or almost all males. So you might do what's called a stratified sample. Say you have a sample of 100 out of these 1,000. Remember, there's 900 males, 100 females. If we want to keep that proportion, we would get split into the males and female population list. Then we would choose 90 males and 10 females. That way we keep that same 9-to-1 ratio that we have in the population. Now, on the other hand, if we're really interested in gender, and that's the most important variable that we're looking at in the study, we might do a disproportional stratified sampling. So that same case, 900 males, 100 females, and we want a sample size of 100, maybe we would take 50 males and 50 females. That way we have equal numbers in our groups to look at various types of comparisons. Even though it doesn't represent, we have a much higher percentage of the females in our accessible population than we do of the males. But that's okay because we're really focused in on that gender variable. Okay, cluster sampling, basically you say classrooms in a school, there's 100 classrooms, maybe you choose 10 and then you sample all the students within those 10 classes. Non-probability sampling is not often desirable, especially for quantitative studies, but it happens. Convenience sampling, you just take the people who you can actually get, people who volunteer to be in your study. This is actually what's often done in medical studies. So medical studies tend to be very good with internal validity, with finding out if a treatment works, but very bad at external validity because they don't have representative sampling necessarily. So by sampling a representative group of the population, you have very strong external validity. Whatever you find in your study can be extended, can be generalized to the population. Quota, just getting a certain number of people, kind of tied to convenience. And purposeful is in qualitative research, where you're specifically going after the people who have the best information, the best data from your population. You don't care at all about random sample. I'm going to go through some of these slides here just to make sure we get everything. So again, volunteer samples, you have to really make the argument that the people who volunteered are similar to the people who didn't volunteer. Sample size, here's one of the few issues where I disagree with the author of your book. So I'm coming from a mathematical perspective. He says 30 participants for testing a correlation, 15 for like an independent t-test, for example. And then qualitative, you need enough participants until you start repeating information. That's called data saturation. So a qualitative study, when you propose it, you often won't even specify an exact sample size, maybe a rough estimate, but then you'll have a line, participants will continue to be interviewed until data saturation is reached. So he's saying 30 for correlation, 15 for independent. Let's take a look at a chart. So these are all based on formula, and we're looking at two things here: effect size, small, medium, large. These are given by Cohen, and it's saying how many standard deviations above the mean are you. But you'll just see it reported as effect size of 0.2 or of 0.3, 0.4. Typically, 0.2 is a small, 0.5 is a medium, 0.8 is a large. Cohen himself hated giving set numbers, but those have kind of become the standard for better or worse. And then power is the probability that if there is a effect, you'll actually pick it up. So notice that you typically would want a power of 0.8 or more. So let's look at that. If you have a treatment with a small effect, it would take you, on average, a sample of almost 400 to pick up that effect. Now, if you had a treatment that had a medium effect to it with a power of 0.8, it would be a sample size of 60, and only if you had a treatment with a strong effect would that sample size that you often hear, 25, 30, only then would that sample size be sufficient to actually pick up the effect. And rarely are treatments this effective in the social sciences. So that tells you that sample sizes typically are a bit smaller than they should be. And for correlations, really, for estimating the size of a correlation, you would really want 1 to 200 at a minimum. Okay? So I think I'm flustered right now because I see that there's a minute left on the video. Let me just jump to evaluating sampling procedures. So no matter what the study is, if it's an empirical study, they should describe these things. They should describe how they're choosing their participants, what % of response they had, how they guaranteed there was no bias. If you don't see these things in there, you should question the credibility of the study. And you should also have these in here for your proposal, at least the ones that can be done beforehand. Response rate, you won't be able to tell until afterwards. A few more here to close off with.